Hello, participants of the General AI Challenge. This is Martin Poliak speaking from Good AI. With me here are colleagues from Microsoft, Honza and Tomáš. These guys will guide you through Microsoft Azure, which was offered to you for free to use in the challenge. So they will guide you through what Azure is, what it has to offer to you, and also we will be doing evaluation on Azure. So they will be showing you some evaluation-related technical details. Also at the end, I will be showing you a presentation which will recap the quantitative evaluation of the General AI Challenge. And I will walk you through some technical details of the evaluation and give you links to the technical documents that describe the submissions. So without further ado, I will pass my word to Microsoft colleagues, and we can begin walking through the Azure workflows.
Hi, thank you for the intro. I'm Thomas, and for start, I want you to notice that we have a Mea app that you can put your question in and ask us, that we will reply and respond later. So I'm here in Microsoft to help startups join our BizSpark program and help them with their technical difficulties. We may have exchanged a few emails in the past weeks regarding sign up for benefits. Today we'll be talking about BizSpark program that since 2008 Microsoft has to support hundreds of thousands of startups across the world and help them go further and faster with its technologies and with no strings attached. BizSpark is an incubation program that Microsoft runs to help startups get up and running in the cloud. So with BizSpark, you get access to a wide range of Microsoft tools like Azure, Office 365, Visual Studio, Windows, and many more. We help them succeed alongside with Microsoft, and it helps us succeed in the future too. So it's kind of like win-win situation for both parties. Now let me show those of you who haven't done it already how to get free credits and other cool benefits. As I mentioned, you can get $750 of Azure Cloud credits monthly for free and other dev tools and software. First thing you need to do is to send me an email to my Microsoft address, where you attach a copy of your General AI registration confirmation, and we can get an enrollment code that will automatically make your request accepted. Please don't forget to mention your project's name so we can keep track of assigned codes. Thank you. Now, when you get the code, you can go directly to bizspark.com and fill up the application that you'll face after you sign in with your account. First off, you'll need to have a Microsoft account. If you don't own one, you can create it right from this sign-in dialog for free. Everything in BizSpark administration is tied to the Microsoft account, so be sure you don't lose access to this account. This is your membership dashboard that you can see in the section My BizSpark at the mentioned web bizspark.com, and if you click on the offers button here, you can add additional members, and everyone will get the same subscription with 150 worth of Azure credits. After you claim your subscription, it can take a few hours before the right information will propagate between the systems, and then you can access your benefits. Only thing you need to do is to go to my.visualstudio.com, and there you'll see all the benefits listed in the nice page in front of you. You can use the mentioned Azure credits as well as other products, or maybe you can find useful the Office 365 offering for your communication. I need to mention there are some limitations for BizSpark. You can create your resources in a limited set of regions. For example, you can use US East. If you encounter some problems, you have few options. You can use billing support that you can contact through Azure portal, and they will have a great response time. If you can't resolve your problem, you can always email me, and I'll try to do my best to help you with your issues. So now I would like to invite my colleague that will show you some quick overview of Microsoft Azure.
Alright, my name is Jan and I'm going to give you an introduction to Microsoft Azure. So first of all, let's start with defining what Microsoft Azure is. It's a global cloud platform which offers three different cloud computing models. The first one is infrastructure as a service, which means that we manage the storage, networking and compute for you, and you specify the virtual machine, the operating system and everything above on it. Then we also provide a platform kind of services which basically allow you to only deploy your application, manage the data in it, and we manage the rest of it for you. Then there is also software as a service which makes it easier for you to just manage the data and you don't have to care about the application that actually is in the background. Now Microsoft Azure is available in many different data centers across the globe, which easily enables you to create globally distributed applications. You can choose multiple data centers, you can replicate your data, your websites, your databases and many other Azure services. You can use failovers to distribute your workloads in case of disaster and many other things. We have around 38 data centers available at the moment, and with many others coming very soon. Then right now on the slide we can see all the different Azure services. You can see that there is many of them, and if we were to explain all of the Azure services to you, we would probably spend like next week doing all that. So I have decided to show you some basic introduction into Microsoft Azure, and then we will look at some very key services which you might encounter during the challenge. So right now I'm going to switch to the browser, and in the browser we can see the Azure portal. The portal is accessible as a website, and you get access to it right after you sign up for BizSpark and you get the Azure like Tomáš mentioned. So on this dashboard you can see that I have an option to create services. So for instance, if I wanted to create a virtual machine, which is the basic key element, I would click the plus button. I would, for instance, I want an Ubuntu virtual machine, so I would go with Ubuntu server. You can see that there are many different images available in the Azure Marketplace. So for instance, if you're looking for a specifically configured virtual machine, you can try searching for it because there is very likely an image already ready and existing which you can use. So I'll just create a plain Linux virtual machine. First thing is to give it a name. So I'll just name it. So then you can choose whether it's going to be using the SSD drive or the classic hard drives. SSD of course gives you faster disk IOs. Then you create a user and you need to specify the SSH key. Then you choose the subscription, so you will usually have one subscription that you have created, and then also you specify the resource group. The resource group is a logical structure of the project. It allows you to separate billing and also move the resources all together. So I'm just going to create a new resource group. Then you also choose the location. You can choose from many different data centers, so probably it's good to choose the closest data center to you. After that you have to choose the virtual machine size. So you can see there are some virtual machine sizes offered for me by default, but you can view them all and you will see that there are many different instance types. So I'll just choose like probably the ESB2, which is a general virtual machine. I can also configure its features. So if I want to use a storage very easily, I can use the manage disks, which actually allows Azure to manage the storage for me. So when I mount the drives, it actually manages the storage accounts and the disk locations, and everything is done for me on the background. I can also specify the networking, which basically allows me to connect virtual machines through virtual networks. I can then connect those virtual networks between each other and also connect them to on-premises. I can specify the subnets and also the external IP address which the virtual machine will be accessible from. Also, note that there are things called network security groups. Those network security groups are basically the firewall, and those protect the virtual machine, and they act as both inbound and outbound firewall. So you can block the outbound connections to the outer internet if you need, and you can also allow specific inbound connections. So by default, you can see, since it's a virtual machine with Linux, I have SSH enabled, but if I wanted different ports like port 80 or 443 for SSL communications, I would need to specify it in the network security group. If I was to deploy the virtual machines like with high availability, so in case one virtual machine goes down on specific hardware on the rack in the data center, I could use availability sets, which would provide me with high availability. I can also enable diagnostics, which are very useful. For instance, you can also enable the guest OS diagnostics, which are basically going to report the data from the virtual machine back to the Azure portal, so you can see how the virtual machine is performing, how it's utilizing its resources. So right now I'm ready to create a virtual machine. And once the validation passes, I can create it, and right now my virtual machine is being created. So it's very simple to create a virtual machine. Once it's created, you get the public IP address. So it's not going to take too long. We can take a look. You see that the public IP address is already here, and it will be allocated very soon, and you will see the IP address which you can then connect to using PuTTY or SSH. So this is the basic virtual machine creation, but that's not everything. You can also use platform services. So in case you need to host a simple web application or an API, you can use those. And we also have something called Azure Functions. Azure Functions are basically the serverless applications which allow you to type code without caring where the function is running. It's very easy to configure them. It's also very simple to connect them with other services, so you can have them act on a new queue input or storage blob being uploaded and so on. So just to demonstrate, I'll just have to give it a name. So I will give it a name. So 1. I will also place it into the same resource group because it's one project. That's a good practice to actually keep all the resources in the same resource group as long as they're related to each other. Then you can choose between the consumption and app service plan. The consumption plan basically acts as a true serverless, so you only pay for what you use, so you're billed only for the used executions of the functions. Or you can specify the app service plan, which gives you dedicated infrastructure, so you always know how many resources you're going to be using. So I'll also again choose the data center, so West Europe is the closest for me, and I'll also connect it to a storage account. So now I have created an Azure function, and we can take a look on how to put some code into it. It's actually still being created. Still getting created, so we'll take a few more seconds. Alright, here it is. So I have now created an Azure function, and now I can just go ahead and create a new function. I can choose how the function is going to be triggered, so it can either be triggered by as a webhook, so it can be called as a HTTP request, or it can be triggered by timer, so it's going to get called periodically like a cron, or it can also process data. So for example, it can be hooked to Azure Storage or Service Bus or other storage options that we will take a look at in a bit. You can also choose a broad variety of coding languages which you can use. You can either use C#, JavaScript, F#, or there is also PHP, Python, Bash, and PowerShell. So we give you a great variety of options how to use the Azure functions. Now with Azure functions, you can do many different things, and you can connect the Azure functions to different data sources. So as you might have noticed, while I was creating the function, there was something called storage account created. The storage account is used for storing data. Now you can store different types of data in it. You can store blobs, which are regular files. You can also use the Azure storage as SMB shares, so you can mount it to virtual machines for persistent storage. You can mount it to containers. You can also use the queues, which act as regular queues. And if you maybe need an AMQP, you would reach for Service Bus. And then there is also table storage, which is a NoSQL, non-structured data storage, which can be also very easily used. And to all those storage options, you can hook the Azure functions to. So whenever there is an event, so for instance a blob is added or a message in queue arrives, the function will get triggered. So it's very simple to get going with Azure functions. Another important chapters are the containers. In Azure we have something which is called Azure Container Service. The Azure Container Service lets you to very easily create container clusters. You can choose from different types of orchestrators. So we have currently support for DCOS, Kubernetes, and Swarm. So based on those, you can choose the orchestrator which you like. So for example, I'm going to choose DCOS here. I have to create a new resource group for it. So DCOS. I also choose the location. After that, I give it the DNS name prefix, which is how the service is going to be reachable through the internet. I have to provide the master account, SSH key again. Then specify the master accounts. I can enable the diagnostics, and also I set up the agent pool. So you can see you can have multiple agents. I can then also scale them independently. I can also use the auto scale features to scale the cluster, and you can also choose the virtual machine size again. After that, you can connect to the cluster. You can deploy your containers to that cluster, and you're good to go. So this is one option. This is another option for doing computation in Microsoft Azure. Now, you can also make use of Windows containers in case you need them, so you can run containers on Windows Server as well. So throughout all this showcase, I've been showing how to do everything in the web browser. But what if you need to automate something? We have currently REST APIs available, so you can call all the Azure APIs for provisioning automatically. You can also use the Azure Cloud Shell, which is a new service we added very recently, and it spins up a container for you, and you can control Azure directly from your browser but using a CLI. So for instance, you can see that I have a CLI here. I'm running it in the browser, and I have all the different options on how to interact with Azure. So I don't have to use the user interface, the graphical one, and I can use the scripting for everything. Now these CLI tools, they can be also downloaded locally, and they can be used cross-platform, so you can use them on Mac, Linux, and Windows, of course. They make it very easy to automate. If you're a Windows guy, you can also use PowerShell, which is very useful as well. So we went over the controls, and now we're going to look at the storage. If you need to store data, you can either use Azure SQL database, which is a cloud-hosted SQL for your workloads. So it basically spins up it's not directly a virtual machine, but it allows you to connect to it as a regular Microsoft SQL server, and it allows this service allows you to scale pretty much enormously for very different broad variety of workloads. We have also recently introduced support for MySQL and PostgreSQL, so you can use those as well. They are fully managed, so you don't have to handle the servers, the connections, the high availability, and everything is managed for you as a platform. Alternatively, if you need, for instance, a MongoDB or some document DB, you can use Azure Cosmos. Now, Azure Cosmos is a service which allows you to use different APIs, either document DB, which is a Microsoft made API. You can use MongoDB, you can use Graph, and different kinds of APIs to access the data. They're stored in a service which is backed by Microsoft and is geographically scalable again. And it's highly available, so you can store a lot of data within that service, and you can access them very easily. You can also create stored procedures. You can create background tasks, and you can also hook everything to Azure Functions, so you can automate the processing as well. So I think this is it for the Azure overview. If you have any questions, please type them into the Q&A, into the MIA Q&A. And if there are none, I will send over to Jan.
Let me just quickly recap what I've just did. I was talking about what are the options, how to do some data processing using data science tool, and one of them is Azure Machine Learning, which is pure web-based interface. It means you don't need to install anything locally. Only prerequisites are like having web browser and access to the internet. Through the first part, I was covering the process of creation of machine learning workspace. I think it's clear even not having audio. So if there are any questions, feel free to use my application to raise the question. At the end, I can do again quick recap, even with walking through the Azure portal and showing how to create the machine learning environment, workspace for you. So once you do have your workspace, you can log in. I'm already logged in, so I just need to go to my workspace. And here you can see all your experiments, all your models which you've created so far. In your case, during the first visit, it will be empty, but there is an option to choose some template or some demo experiment, and they are covering most common scenarios for classification, even some deep neural networks and the others. So I will encourage you to go through to choose the one which is closest to your solution, and I will walk you through some basic to cover the main capabilities of Azure Machine Learning. So let me start with the data. So first thing you gonna need for your experiment is to have a training data set. So you have number of options, and let me cover the two which are most common. The first one is like you can upload the data set directly to the machine learning environment from a local file. There's a number of options which data types or type of the data set can be uploaded. The most popular are CSV or R objects, which can be uploaded directly with no further, let's say, modifications. So this is the option number one. The second option is to have a data importer. Having a data importer offers you some additional ways how to not just upload the data, but how to take the data from outside. And this can cover even scenarios like you don't want us or let's say Azure be aware of any customer data or let's say third-party data at all. So in this case, the data will go through the model and not be stored anywhere on Azure. Just some metadata in case of pre-trained model will be there and nothing else. Together with that, there is a limitation about how you can use the machine learning which is being created using the machine learning studio. The experiment is tightly bounded with Azure environment. It means you cannot take the pre-trained or fully trained model out of Azure. Actually, it's not fully true nowadays because a few weeks ago we announced functionality called IoT Edge, and there's a option how you can take your model out and let the data being processed somewhere else, even offline. In case you are interested in, feel free to drop me an email and I will send you more details about that functionality, but be aware that it's in public preview only and you have to ask for that functionality to be enabled on your subscription. So it's not that easy to get to that functionality, but there is a way how to do that. So feel free to ask if you really need it. So this is how you can take the data from outside of machine learning to be processed by Azure Machine Learning. And the same with the data output. There is a data export which can help you to put the process data out of Azure. So regarding some demos, I do have 5 of them already prepared in my workspace, and let's start with some neural network because I think this is one of the famous and it's directly supported on AML. So this is the easiest experiment you can create using the Azure Machine Learning Studio. Especially this one, there is a number of handwrite, I think, numbers and characters, and there is a neural network trying to, let's say, guess what's on the picture based on some training data set, as you can see. So we do have 2 different data sets, the training data set and the verification data set. For the training, we are using, as you can see, multi-class neural network, which is fully defined by a script. For scripting, we can use a special language called NetSharp, I will cover at least the basic from that language a bit later. Or if you are okay with just default, and by default I mean one input layer, one hidden layer, and one output layer, you can choose like fully connected network. And in this case, you don't need to write any code, just define the basic of your network, like how many hidden nodes will be in the hidden layer, and few more. So let me go with the custom script definition. And as you can see, the definition of that network is really like very simple. You just need to define how the input layer is, how the output is, and as much hidden layers as you want. You can even skip the definition of how many nodes will be on the input and output by putting auto. Full description of the NetShark can be found under the help. So if you click more help, it will guide you to MSDN documentation. And there is an article about NetSharp and how you can define your very own network, doing whatever you need. So this is this, as I said, this is the simplest network or experiment you can create. So there is a training part, there is a scoring part. Out of the scoring part is a confusion matrix. Then there is a evaluation. You can compare even two different network to distinguish which one is better or perform better. And that's it. Once you have your network trained, you can. It's not meant to be used just through the machine learning studio, mean the output. Of course, you can connect your own data set which you like to get processed, or you can create a RESTful API out of it. So let me choose a different experiment. It's not that much important what the experiment is doing. I think it's looking for some outliers in a data set. And you can amend it with the web service input and web service output. So as you can see, web service input and output, then you have to rerun or reprocess your experiment. And once it's done, you can deploy a web service out of that experiment. So let me walk you through that process. By the way, do you remember we were choosing the pricing tier for our Azure Machine Learning Playground? So all the limitations which were mentioned there applies to the web service as well. So there were a number of calls mentioned and few more parameters. So all those parameters applies also to a web service. So you just need to select the name. You have to select one of the price plan you have created in advance. So I do have just one. Then you can deploy. It should take not more than a couple of seconds, I hope. Usually it takes for like up to a minute. maybe in the meantime, oh, it's done. So doing that, you have a RESTful API with some specific endpoint, with some specific secret key for authorization, and that endpoint can be consumed from literally anywhere. So you can incorporate it, what you've done using the Azure Machine Learning in your system or any third-party system. So access keys, you can add even some description, and there is a description of a web service which has been created. I do have even few more from the other experiments, but this is the one we've just created. There is even a Swagger description for the API, so if your third-party system or your own system can understand the Swagger definition, you can, let's say, include the API directly using a Swagger definition. It seems like it's not fully created, but as an example, I think it's enough as an example. So there's a number of methods about API description, then how to let API or machine learning process the data, and everything can be done synchronously or asynchronously. Let me get back to this bit later, because we are still in process of creation that API. So in the meantime, I will cover some other scenarios for machine learning. So one of the most advanced scenario are the convolution networks with some deep pooling. So this is an example how you can define a fully connected neural network with some convolution in it and with some deep pooling. I forgot to mention at the very beginning that one of the limitation Azure Machine Learning has, or not the Azure Machine Learning, but those pre-built stuff has, is like you can have just one output per model. So if you are looking for models having multiple outputs, you have to define it by yourself using Python or R language. About Python and R language support, it's like we do have up to 20 building blocks prepared for you, like which can be used out of the box. And for scenarios which cannot be achieved by those building blocks, you can create your own definition using, as I said, Python or R script, and let those scripts running as a part of Azure Machine Learning. I will get to that point a bit later. So let me just walk you through or show you how the convolution can be defined. So this is the input layer, and then there is a number of twins like convolution and some pooling. So by having that, you can create even complex scenarios like image processing, maybe even audio processing, or whatever you need. But keep in mind that Azure Machine Learning, covering just let's say, basic or the most common scenarios. And if you are looking for some more advanced, I will be talking about what's called CNTK framework, which is um, available for you for free. And just a teaser, it's something similar to for example TensorFlow. So if you are familiar with the TensorFlow, so the CNTK can be the right choice for you, because the CNTK is Microsoft based, and it's primarily supported on Azure. But let me get back to. Okay, there's a question. So, uh, oh, it's question about the REST API, if I get it right. Like, if the code generated by Azure Machine Learning running as a REST API can be modified or not. Am I right? So, the API or the process of creation of API is fully automated. So you can tweak your model as far as you like to or as you can using those building blocks. But once the experiment is done and calculated, the REST API cannot be modified. I don't know if the question is related to, for example, columns or some additional parameters. If yes, everything has to be as a part of that model. So if you are looking for some additional parameters or anything else, you have to amend your model in Machine Learning Studio and then redeploy the API. So make it simple. There is no option how you can manipulate with the source code of that API other than by modifying uh, the project in Machine Learning Studio. Let me get back to the samples I do have for you. So as you can see, creating of some even advanced scenarios like neural network can be very simple, but keep in mind that there are some restrictions like single output. But for most cases, uh, it should be enough. If you are looking for some advanced scenarios and you still like to go with the machine learning, not touching any Python or R script, let us know, because there is a huge team of data scientists creating new models which can be then used out of the box for you. So the user voice is really what makes a difference. So if you are looking for something cannot be covered at the moment, just raise your voice and let us know, and it can be including in the next release. We are releasing new functionalities like at least once a week. So the machine learning is one of the services going through really rapid development during last year and a half. So there's a high chance to get your scenarios covered with a new release. Azure Machine Learning can be used not only for, let's say, data science, but there is also a number of options how you can manipulate the data. So if your data set is not in a condition you'd like to have it, you can do the yak shaving part also using the Machine Learning Studio. So there are some building blocks looking for some incomplete data, or you can do some data swap, uh, and much more. Uh, as I said at the very beginning, the number of building blocks ready to be used out of the box is like 200 nearly. And if we take a look only to the machine learning part, there are four main areas like anomaly detection, classification, clustering, and regression. And for each and every, there is like up to 20 building blocks prepared to be used, as you can see. I hope you can imagine what you can achieve by using those building blocks, because there are some, uh, all of them are like basic, and you can find a documentation on MSDN for each and every one. If you place any building blocks, there is a more help button in a quick help window, which leads you to the full description of the building block. I was talking about Python and R support inside of the machine learning. So let me just quickly cover this part. As you can see, you can add some Python script or R script as a part of your model. You can choose which environment it's gonna use, and then just paste your script into that building block. You can even use imports. So all the libraries which are publicly available can be imported mm, just by import declaration. There is no need to include all of them as a part of the script. If your project is more complex, there's a way how you can zip all your files, create a bundle, and then you can upload the bundle directly to Azure, or even the bundle can be placed somewhere on the internet, publicly accessible, and you can just point the machine learning to that bundle, so you can update the bundle not touching the original experiment. So Python and R script. So this is basically it. This is the Azure Machine Learning Studio, and how you can create your machine learning experiment, not writing a single code of line, except of course the Python or R. But I will encourage you to walk you through the demos. The demos are covering the common real-world scenarios, and I'm pretty sure that you can find them inspirational. So the second part will be about the CNTK and data science virtual machine. I was talking about the CNTK even during the machine learning part. So CNTK is a framework for data processing uh, fully done by Microsoft. And just to compare the set of functionalities, you can consider CNTK as a Microsoft version of TensorFlow. So those scenarios which can be covered by TensorFlow can be covered even by CNTK, and much more. And just as a teaser, if you are familiar with cognitive services from machine learning like Face API, Vision API, Text API, and all the others, all of them are based on CNTK. So I think this is a great example demonstrating the power of CNTK framework. CNTK is, as you can see, open source, so it's not like we do own all the intellectual property, so you're gonna be some kind of vendor locked. Not really. You can take whatever you need and modify it according to your needs. CNTK is also a part of what we call data science virtual machine. So let me dig a bit deeper into what the data science virtual machine is. So if you'd like to do some data analysis, in most cases you need a really powerful machine to do all the computation. So you have two options: to buy an expensive bare metal hardware, or you can let Azure to provision a data science virtual machine for you on Azure using credit which is available for you as an Azure subscription. There is a description of DSVM on the Microsoft documentation. So this is the page I'm showing you at the moment. So as you can see, all the common tools which can be used for data science are already installed, like RStudio, R Framework, Python, Conda environment, and much more, even some Spark stuff, and not just a framework. There is a set of tools or even tool chains available for you, like RStudio, Visual Studio Code, and the others. The data science virtual machine is available as a Windows base or a Linux base. And let me walk you through the process of creation of that virtual machine. So if you search for data science, you should find at least those two, like data science for Windows and data science for Linux. There is even the third one, this one, like deep learning toolkit for DSVM. And the difference between or among those three is like deep learning virtual machine is meant to be used together with N series instances of our virtual machines. N series refer to GPU calculations. So N series are available with the GPU or maybe even multiple GPUs, but be aware that price of that virtual machine is a bit higher than the regular one. But the computation time for your project can be like much more less. So I did some comparison using FastR neural network. So having 4 CPUs, my calculation was like hour and a half. Having a single GPU, we are offering the Tesla GPUs, the calculation took like just 1 minute. So it's much expensive, but the processing time is significantly less than using the CPU. So let me get back to process of creation. So it's basically the same as with any other VM, and Honza was covering that process during the second part. So you just need to fill down some basic parameters. This is the important part. Come on, come on. This is the point where you can choose which type of virtual machine will be provisioned for you. So if CPU or GPU based. This is the beauty of live demos. If you want to show something, there is a glitch. So let me skip it for now. We can get back to this bit later. I've created two different data science virtual machines in advance for demo purposes. So I do have one which is GPU based and the second one which is CPU based. This one. Both are running Windows, but working with the virtual machine is basically the same. So let me show you one quick example of CNTK. There's a number of examples already prepared. So once you create the virtual machine, you can navigate to DSVM as data science virtual machine, to CNTK and examples. There are a few examples about image processing, about voice processing, about the video processing. So let me choose the image processing, and one of the easiest or let's say easy to reproduce and to make it working is the detection. So you can use the CNTK for image classification using FastR. There's a number of scripts already prepared for you for, let's say, data selection. Like all you need to do is upload a bunch of images which will be used as a training data set and as a verification data set, and then you have to pick what's important to you on those pictures. And let me show you the real demo. So images, examples, data sets received. So this example is about the automation of received processing. So if you want to do your expense, you have to do it manually. So because I'm like lazy to do that, I'd like to automate the process somehow. So one of the challenges is to pick the right values out of the receipt, like date, like mount, and few others. So I do have few receipts like this one. Let me just take an example. This one is from Starbucks. So firstly, we need to create a train data set or prepare some metadata over the data set to let the FastR understand the data. C1. It should take not more than a few seconds, I hope. Or maybe not. Let me double check the script. DSVM. It seems okay. Let me try to rerun. Okay, it's not working. To be honest, I don't know why, and I don't. There is some progress. Perfect. So, as a first step, we'd like to know what the retailer was. So, we can identify the retailer by logo or by the name or anything else. So we have to mark all those regions on the receipts we are interested in. Once we're done, we have to assign labels to those regions. Now it will go through all the regions I've selected in the previous step, and I've made a list of possible labels in advance. So I just need to select, okay, so like this is the Starbucks, even this one, even this one. I've processed just one image, so that's it. And then we have to, because the number of images I'm using is not enough, so we can let the CNTK multiply the regions of interest, aka those boxes, to have more input data for the training. So let me cancel, because I've marked just I did the work or just over the one image. So it can multiply the region of interest, and then the funny part, the learning. The learning, as I said before, can be done using the CPU or GPU much faster, but cost more if you are running the GPU on the Azure. And at the very end, I can show you how the outputs can looks like. V3. Not this one, sorry. Yeah. The labels are wrong, but it was my mistake because during the process of initial labeling, I've labeled Starbucks as KFC. I don't know why, but I did it. But as you can see, those are test images which were never processed during the learning, and it can detect at least the logo, in some cases even the text on the test receipts. And this project can be again published as a RESTful API on Azure as a part of web application. Honza was talking about the web applications just an hour ago, so you can take your Python code, you can take the pre-calculated network and let it running on Azure. The benefit of CNTK is also, and it can, let's say, differentiate the CNTK from the Azure Machine Learning also, that the code can run anywhere. It's not bounded to Azure only, so you can let it running even on your local computer or any other cloud provider out there. So we are running out of time slowly. So are there any questions? Not yet, so feel free to ask if something is unclear, or you can ask later. I think the contact information will be part of the recordings, or you can use the Maya application even not just during the webinar, but even the later. We will be on it at least till end of the week or end of the challenge, so feel free to reach even through Maya, but we prefer email communication. So I'm now handing over to guys from Good AI to their presentation, and even during the presentation feel free to ask any question.
Thank you, Hansa. Hi, it's me again. It's Martin Poliak. I will be walking you through some details of evaluation criteria. I will mention a bit about the tasks, and I will walk you through some workflows related to submissions. We already had some questions. How do I submit my agent? What port do I connect to, and so on. So I will touch this a little bit, and then I will link you to detailed how-tos. So first we'll look at what the objective of the challenge is. We'll review the prizes, and then we'll jump to the evaluation. We'll see what kinds of evaluation there are. We'll look closely on the quantitative evaluation and its criteria, and then go through technical details, especially technical details of the submissions, and there's also some frequently asked questions. So the objective of the challenge is to create a gradually learning agent that learns how to solve new unseen problems. This first sentence here is really the core of the challenge. Your goal is not to solve some task. Your goal is to create a system that can reuse acquired knowledge for acquiring new knowledge, and then use it to solve new problems, gain experience of those new problems, and then use that experience for solving new problems again. So you're basically solving continuous learning and overcoming catastrophic forgetting. I think we can go to the next slide. Review of the prices. As you all probably know by now, there are two kinds of prices: quantitative price and a qualitative price. The quantitative prize will be given to the winner, or the first three who solve all evaluation tasks, and they use gradual learning. They reused the learned skills, they do not forget old skills, and of course, if both of these conditions are fulfilled, then the solution with the smallest number of simulation steps is the winner. There is also a qualitative prize, which is evaluated differently. A jury will be set up, and they will select the best papers from the submissions. Also, they will look at the quantitative winners, and they will evaluate the ideas in your solutions. And the most promising idea or solution for scalable gradual learning will be declared the winner. The qualitative prize can be given even to a white paper solution which has no implementation, but if you implement the solution that you propose, that is a big plus, because by that you're actually showing that your idea is working, that you put some time in making sure it's working. So let's go to the quantitative prize. You already know that there is a training curriculum. The training curriculum contains 40 tasks. The hardest task in the curriculum are ComAI mini tasks. We'll review them shortly. And of course, they have this gradual property. The more difficult tasks built on top of the easier tasks. In the evaluation, again, there will be 20 to 40 tasks. Right now we're creating the evaluation tasks. We already have the hardest tasks. We know where we will guide you, or we will guide your agent, but of course we cannot tell you. We will tell you after the challenge submission deadline. We will show you what the evaluation tasks are. Of course, again, there is this gradual property. What is important, having pre-trained on the training tasks is a plus, because your agent has some additional knowledge, but it's not sufficient, of course. You cannot just hand over an agent that knows how to solve the training tasks and cannot learn and think it will solve the evaluation tasks. No, the evaluation tasks will continue new problems, unseen problems that you will have to, again, learn to solve, or your agents will have to learn to solve. As I promised, just a quick review of the hardest tasks in the ComAI mini set of tasks. Those tasks, they first propose some kind of language. For instance, the first line here reads description, and then the language contains of substrings FAB or GH or MIL, and then you're given some word from this language, and you have to say whether it really is from that language or not. And then we'll say, okay, you answered correctly, or no, you didn't answer correctly. The hardest tasks in the evaluation curriculum will be similar to these. They will not be the same. How much similar or not, well, you will learn yourself after the evaluation is over, but rest assured that we tried our best to make sufficiently different yet sufficiently similar tasks, so that if you can solve the training curriculum by means of gradual learning, you should be able to solve the evaluation curriculum by means of gradual learning. This here is a schematics of the quantitative evaluation. It just shows two kinds of submissions. First is a submission on top, where you start with an untrained agent. We call this agent alpha. It goes through public training curriculum, it acquires some knowledge, and then you send this agent to us for evaluation. And this agent is trained on the evaluation curriculum, and perhaps it's such a good agent that it solves all tasks. So here on the right, you see that we put him in the leaderboard table on top, and we say, this agent is the best, it solved all tasks. And we record the number of simulation steps. If there's some other agent that solves all tasks and requires less simulation steps, then we say that other agent is better than alpha. Of course, you don't need to do pre-training. You can submit a clean slate agent that knows nothing, only has those biases that you pre-encoded into it, and you can submit it to us and we will run it on the evaluation curriculum. Perhaps it will solve all tasks, perhaps not. We think it's a good idea to at least try some pre-training. And in this example here, you see that agent beta, it didn't solve all tasks. It's solved 14 of the tasks, which is worse than alpha, even though that beta needed less simulation steps than alpha, but it solved less tasks, so it's not as good. It cannot be the winner anymore. Recap of the evaluation criteria. To win, you have to show that you're reusing skills. So if you know some prerequisite skill, your learning of next skill that depends on this prerequisite skill should be much faster. That's the first line. Second line, demonstrate not forgetting. So if you learn some skill, S1, and then you learn skill S2, then you should be able to learn S1 much faster than without ever knowing skill S1. Ideally, you will not need any time to relearn S1, but of course we understand that if you learn something and then you learn something different, you might start forgetting about S1, but you should not forget to that extent that you, when faced with S1, with the problem that is solved by skill S1, you seem to have never seen S1. No. You should retain some memory of having the capacities to solve problems solved by skill S1. Last line, and that's perhaps the most important, you should solve all tasks from the evaluation curriculum. If you do not solve all tasks from the evaluation curriculum, you cannot win. Now some details about the submission. You can create a Linux-based solution or Windows-based solution. In case of the Linux-based solution, we will evaluate your solution on an Azure virtual machine provided by Microsoft. You will submit your solution inside a Docker image. You will upload a Docker image to a URL that you will receive from us in an email. Don't worry, you will receive that URL well before the deadline, so we have plenty of time to upload that image. And we'll evaluate that image by some automated evaluation script. In case you will be submitting a Windows solution, again, we will evaluate on an Azure virtual machine, but this time not within a Docker, because there are some problems with Windows virtual machines and Docker running inside them that would like to use GPUs. So rather than having two different kinds of how to evaluate Windows solutions, we decided that we will skip Docker on Windows, most probably, and you will basically submit your solution with a how-to or a guide or README that will explain how we should run it on the virtual machine. Of course, since this will not be run inside the Docker, there might be some occasions when the solutions would like to connect to internet or maybe even tamper with the ComAI environment. Well, we'll monitor for this kind of behavior, and if such an agent starts connecting to internet or modify ComAI environment, it will be disqualified. You cannot do that. In the evaluation, you are not allowed to connect to the internet. You're not allowed to modify the evaluation environment. We have created detailed how-tos for submissions of the Linux solutions and of the Windows solutions. Those how-tos include steps for you to how to verify that your submission is correct. You can actually mock an evaluation yourselves, so you see that everything is working as expected. There are no errors, no exceptions, and we will publish these how-tos shortly, like within a few days, and you will receive a notification, so you can try the submission yourself. Just a few more details about the quantitative evaluation. The pre-training will be done on your hardware, and you have unlimited time for doing that. You can also use the Azure VMs using your Azure subscription. The evaluation will be done on an Azure virtual machine. Your agent will have 24 hours of real time for running, and we will measure how far it gets. An important thing is that we appreciate data efficiency. So fewer simulation steps is better than a fast solution time. And we will not restart an agent that crashed, is deadlocked, etc. So that leads me again to please deploy your solution in Azure within a simulated testing environment. Make sure that it works correctly, that there are no problems for evaluation, because we will be evaluating exactly the way that we describe in the how-tos. You can try that way of evaluation and make sure that your agent is working correctly. And one more technical detail, you will be uploading your solutions to Azure Cloud Storage. We will give you the link in email. Now some questions that participants ask. So one is, do I need to solve all evaluation tasks to win the quantitative prize? The answer is yes. You cannot solve just the most of all participants. You need to solve all the tasks in the evaluation curriculum. If nobody solves the evaluation curriculum, then we will not award the quantitative prize. But fear not, we still want to find an agent that has the capability of gradual landing. So we in such case that there is no winner of the quantitative prize, we intend to analyze where were the biggest difficulties and improve and rerun the warm-up round. Maybe make some adjustments and small changes, so the curriculum might be even more gradual, there might be some more extra meta information available for you, etc. So that's the presentation I had prepared for you. Now maybe there are some questions. If not,
No, not really.
no, that's not a problem. You can pose those questions, they will be answered afterwards. Or you can send them to us on the forum, for instance. So thank you for watching. Thank you for listening. And that's it. Thanks.